Welcome back to Understanding VXLAN using BGP EVPN. This is going to be video 6. So we're going to start with this command here, fabric forwarding anycast gateway MAC, and this MAC address. This MAC address can be anything that you want it to be. This command right here is going to go on every single VTEP. Alright, so let's try to explain this command here. Okay, so I'm going to give you several explanations. Hopefully you will get it by the end of this. So this command is a global entity for your entire fabric. If fabric forwarding mode anycast gateway is on the SVI, then this command is the actual ID card that every switch shows on the Ubuntu desktop. In a VXLAN EVPN fabric, you want every VTEP to act as the default gateway for your users. Let me read that again. In a VXLAN EVPN fabric, you want every VTEP that you see here. I know you don't see the fourth one there, but it's right there. So you want that command on every VTEP. Okay, so this command defines that it's a shared MAC. So instead of the switch using its own unique hardware MAC address, it uses this virtual MAC 000.abcd.beef. Now I went ahead and tried to be funny there. I put beef in there. But that is inside of the hexadecimal that you need for the MAC address, right? So it uses this virtual MAC for every VLAN that has anycast gateway enabled. Okay, so this is kind of how it works here in VXLAN. So when your Ubuntu desktop, this one right here, 10.10.0.50, sends an ARP request for the gateway of 10.10.0.1, which would be this one right here, it receives the MAC address of this right here. That's what it receives in the response. If that desktop moves, if this desktop right here moves to VTEP 2, it's going to ask for that gateway again. VTEP 2 is going to give the exact same MAC address. Okay, the desktop never has to be updated or has to update its ARP table, so the connection never drops. Now, if it's like you're in different buildings, then of course the connection is going to drop. But then as soon as you move this desktop over here, if you have a port that's open here that is in VNI 10010, as soon as you connect it, it's just going to come up as if it was never moved. A lot of times this is more like cloud-based networking, right? So they're virtually moving desktops. So when you do move it, it doesn't see the drop, right? So since the MAC is the same everywhere, the desktop always sends its traffic to the closest VTEP. It doesn't have to go searching across the fabric for a specific hardware address. So why do they share the same MAC? Well, it might feel weird to have multiple subnets like VLAN 10, 20, and 30 using the exact same MAC address, but this is the magic of VXLAN EVPN. For the default gateway, each one of these computers is going to have their default gateway of, I configured it of .1. So default gateway of this guy is going to be 10.10.0.1, this guy 10.20.0.1, and this guy 10.30.0.1. And as you're going to see later on, that's going to be the exact same default gateway we're going to use for all four of these guys. And that's kind of why I was saying that if you move a desktop to another VTEP, if it's on the same VNI, it's going to have the same default gateway along with the same MAC address. So you may be asking, is there going to be conflict? No, there's not going to be any conflict because these are different layer 2 domains. They're going to be different VNIs. There's no risk of a MAC address conflict between the VLANs. Alright, let's continue configuring. That's going to be my layer 3 VNI. We'll go over that in a little bit. We're also going to go over these next prefix commands a little later, but I'm going to go ahead and put them in now. go ahead and expand it so you can see it. Oh, what's going on here? Okay. Okay. No router ID. Okay, so we need to configure router ID. I'll go ahead and enable OSPF and BGP. Okay, let me try to apply these commands again. All right, there we go. All right, let's just go over VLAN 500, what it is, what this is here. So VLAN 500, while VLAN 10 was for your Ubuntu desktops, right? VLAN 500 is a layer 3 VNI SVI. So it's going to be the layer 3 VXLAN network identifier. It's going to be, this is going to be seen as an SVI. So this is basically layer 3, right? So again, what is VLAN 500? Think of this as your virtual door to the hallway. So let's say you have a hallway, and in the hallway you have other rooms. Those rooms are going to be VLAN 10, VLAN 20, and VLAN 30. Well, you can't get to those rooms unless you have a hallway. This is where your layer 3 VLAN 500 comes in. It's the transit road, it's the hallway. It's the actual physical doorway to this specific switch that lets traffic enter that hallway. Alright, so this is very important. So even though it's a VLAN interface, it will never have an IP address and no physical device will ever be plugged into it. Its only job is to provide a hook for the layer 3 VNI 50,000 to attach to the VRF, which we're going to go over. VLAN 500 is going to be associated to Tenet A. We'll see that later. Tenet A is going to be a VRF, so it's going to have a different routing table. Any traffic that needs to be routed across the fabric for Tenet A should be sent through this interface. In another part of this config under VLAN 500, you're going to see we're going to put the command vn-segment 50,000. This creates the bridge VRF to VLAN 500 to VNI 50,000. The encapsulation happens When it sees traffic coming through this VLAN 500 interface, it wraps it in a VNI 50,000 header and sends it to the other VTEPs. Actually, you see it here. I had already typed that in. I'll go ahead and stop the video here. I'm going to go ahead and just start with this command here, these next three. In the next video, it'll be video 7, I believe. Okay, I'll see you in that video.